Alright, so some characteristics of inverses. So inverse so this is f of x. The inverse notation would be f inverse of x. That's just the regular function. And this would be the inverse, just because of the -1 there. They are always symmetrical to y equals x. Okay, so they're symmetrical with the line y equals x. And I'm going to give you, well, I'll give you an example of that. So if you have let's say this right here is f of x, and this is the line y equals x. Then the inverse of it has to be flipped across the line y equals x. This is y equals x. So this is what the inverse is going to look like. And you can see that's f inverse of x. If you folded it right on the line y equals x, it's going to land on the original. So f of x and f inverse of x are symmetrical with the line y equals x. Okay, so that's the first characteristic of inverses. So if I knew that this red one was the function, its inverse is going to be symmetrical with y equals x. Another characteristic is the domain and the range are switched. So I'll give you an example of that. So if I know that this is my original function, so my original function is just f of x here, and all it is 4 dots on the graph. Literally just -1, 8, dot 4, 2, dot 0, -1, and 8, 6. If I ask you to tell me what the inverse is, this is f of x, then the inverse, so x, f inverse of x, well, the domain and the range switch. So now my domain, which was right here, becomes my range and my inverse. So remember, domain is the x values, the range are the y values. So now they switch, so it's 8, 2, -1, 6, and then my range on my inverse, -1, 4, 0, and 8. This is my f inverse of x. Okay, so the domain and range switch. Alright, another characteristic. F of g of x equals g of f of x, which both equal x. So if I know, let's see, I'm going to come back to that one once we figure out how to find inverse. There's only one more thing here. To find an inverse, interchange x and y, and then solve for y. Okay, so that's how we find the inverse, and I'm going to show you an example of finding an inverse here now. Okay, So those are the 4 things. They're symmetrical with y equals x if we graphed them. The domain and the ranges switch. This must be true in order for them to be inverses. If you put g of x into f of x and f of x into g of x, you should get x. And then to find the inverse, you interchange x and y and solve for y. Alright, so here's my example. Find inverse. So let's say f of x equals 2x cubed minus 1. Alright, so to find the inverse, we have to interchange x and y and then solve for y. So think of this f of x as just y. And now we're going to switch x and y. So that's now x equals 2y cubed minus 1. So we've now interchanged x and y. Now we just have to solve for y. Get y by itself. So adding 1 divide by 2 and then cube root. So y equals the cube root of x plus 1 over 2. So just to write my answer, this is my inverse. So f inverse of x equals the cube root of x plus 1 over 2. And it's the same process every time process. Just interchange x and y and then solve for y. Alright, so if I know that this is my original function right here, and this is my inverse, if we graphed them, they should be symmetrical with y equals x. So I'm going to quickly graph them on here. So 2x cubed minus 1, and then cube root of x plus 1 divided by 2. I'm going to do a zoom square just so it's like the x's and the y units are the same. And I'm also going to graph y equals x just to show you that. Oops. Alright, too much for the calculator right now. It's confused. So you can see that it is symmetrical with line y equals x. They go right across it. And the last thing we talked about is f of g of x has to equal g of f of x, and that should give you x. So I'm going to plug g of x. Oh, this should be f inverse of x. F inverse of f of x and f of f inverse of x. So back here, g of x is the inverse. It's confusing that I did g. F inverse, f of f inverse of f of x. Okay, so we're going to plug this one into that one. We're going to plug this equation into the original equation. So it's f of f inverse of x equals 2. That's my original. I'm going to plug my inverse in for x right there. So the cube root of x plus 1 over 2. And we should get x. Well, the cube root and the cube undo each other right away. So that just becomes x plus 1 over 2. And these 2's cross off, so x plus 1 minus 1. So we end up getting x, which we have to in order for them to be inverses. Now going backwards, I know this is all confusing here. A lot of information anyways. We're going to put f of x into the f inverse of x. So we're going to take this one and we're going to dump it into the other equation. So it's the cube root of x, which is 2x cubed minus 1, plus 1 all over 2. So we plugged our other equation, our f of x, in for x right there. And the minus 1 plus 1 undo each other, so it's 2x cubed over 2. And the 2's cross off, so it's the cube root of x cubed, which is just x. Okay, we're going to have to spend some more time doing that. I didn't do a great job explaining it because of the g and the f inverse of x, and it's confusing just what to do, what to put where. So we're going to have to do more examples of that. But that's inverses. Any questions? I mean, I'm sure you have a lot of questions, and you're just going to have to try a few.